In the not-too-distant future, the world faces a critical challenge: the ever-increasing demand for food, coupled with the depletion of traditional sources. Overfishing, habitat degradation, climate change, and pollution threaten the health and sustainability of ecosystems. By 2050, the world's population is expected to reach nearly 10 billion, and the demand for food is predicted to increase by 50 to 60%. Aquaculture offers a solution to these challenges by providing a controlled and sustainable environment for fish production. However, as the industry flourishes, so do its challenges. The rapid growth and intensification of aquaculture can create a perfect breeding ground for diseases that could decimate entire stocks, and the use of chemicals or antibiotics has threatened the environment in the past. Sharing a passion for both the environment and humanity's well-being, researchers Dr. Thomas Meinolt from the Leibniz Institute of Freshwater Ecology and Inland Fisheries in Berlin, Germany, and Dr. Thora Lieker from the Faculty of Fisheries and Water Protection in Budweis, Czech Republic, team up to develop sustainable aquaculture practices. The idea is as simple as innovative: to mimic nature. Fish in natural waters do not live in clear tap water. Microorganisms degrade dead plant material, thereby producing humic substances that brown the water. Up to 95% of dissolved organic carbon in aquatic ecosystems are humic substances. These substances have been shown to provide many benefits to fish and other animals by improving growth and digestion, reducing stress responses, and activating the immune system. By adding such a humic substance to the water of juvenile rainbow trout, the team aims to improve the natural defensive mechanisms of the skin mucus, thereby helping the fish to protect themselves against invading bacteria without the need for chemicals. The mucus from the skin of fish was carefully collected, and the activity of several antibacterial proteins inside the mucus was measured. One of the most important defensive proteins is lysozyme. It breaks down special structures only found in the bacteria cell wall, thereby effectively neutralizing bacterial pathogens. Several mucosal immune parameters significantly increased after exposure to the humic substance. Therefore, the effect against an actual fish pathogen was determined. Bacteria and mucus samples are mixed carefully and spread on special agar plates to facilitate bacterial growth. Special precautions must be taken when working with living bacteria to prevent contamination and spreading of the bacteria. After 48 hours of incubation, the plates are ready for counting the bacteria. Interestingly, the mucus from fish kept in humic substances reduced the growth of the fish pathogen by over 40%. As the demand for fish continues to grow, aquaculture is a critical pillar in achieving global food security while reducing pressure on natural fish stocks. Ongoing efforts are required to address environmental concerns and promote responsible and ethical practices within the industry to ensure its continued success in meeting future seafood demand. By investing in sustainable practices, such as using natural remedies instead of chemicals and antibiotics, we can ensure that aquaculture remains a reliable source of safe and nutritious seafood for generations to come.